There we go. I just sent it.
Okay,
There.
I got it. Which page do you want to start with? One on the left?
Let's start with the front page.
One on the left or right? I can't see which is the...
The one on the left.
Okay.
So I've done it, but I'm just still kind of confused on on the top part how to do the domains and the
Uh-huh.
domains of those. I'm just not sure how to
All right.
really do those.
Domains are what X can be.
Uh-huh.
Usually what it is you figure out what X cannot be. It's the best way to approach domains. Okay.
Uh-huh.
If I look at the first function, there's no restriction on X.
Uh-huh. That's just going to be a problem.
It doesn't violate anything. Okay. But if we look at number 2, same thing.
Uh-huh.
As long as I'm taking the square root of a positive number, that X can be positive or negative. Same, all reals, and that's the way you write all reals in interval notation. But now if we look at number 3, the first thing we see is that whatever is under the radical sign has to be greater than or equal to 0. So if my function is this, let me write it. Well, the very first thing I'm going to do is solve this inequality. I'm going to take whatever's under there, no matter how complicated, and force it to be greater than or equal to 0. Because I cannot take the square root of negative numbers. I can take the square root of 0. And if I solve this, go ahead and solve that for me. What do you get?
Let me do that real quick.
Looks like you did it. I forgot you'd done these already. Here, I can follow your work here. Yeah, you subtract 5 from both sides, and then you divide by 2, and that gives you X. I divided by a positive 2, so I don't have to switch the directions. X is greater than minus 5 halves. And so that's a good answer, and that should be bracket, not parentheses. It looks like it is a bracket. Because it can be equal to minus 5 halves. That does not violate the domain.
Okay.
Okay.
Yeah, that one was pretty good.
Okay. Number 4, very first thing you want to do with 4 is factor the bottom. Because that tells you what X can and cannot be equal to. In other words, once we factor the bottom, then the function looks like this. G of X equals 2X over X minus 7 times X plus 7.
Okay.
And that tells you that X cannot, in other words, the domain comes down, there's no way X can be equal to 7, and there's no way X can be equal to minus 7. Both of them would cause division by 0.
Okay.
So, to write that in interval notation, minus, always start at minus infinity, minus 7, in combination with minus 7 to 7, in combination with 7 positive infinity. And those are all parentheses, no brackets at all. It cannot be equal to minus 7.
Yeah. Okay.
Or 7. And infinities always have parentheses. There's no such thing as a bracket around an infinity.
Yeah.
Okay. Let's look at number 5, correct? No restrictions. Even though you can't divide by 0, no matter what X is, that denominator is always positive. If you take a number and square it and you add a positive number to it, you get positive number. You don't. It's impossible to make that equal 0. And that's your domain, all reals, yeah.
And then number
6, the only thing you care about is 3x minus 7 equals 0, solve, and that tells you what X cannot be. So what you're really solving for on number 6 is this. Really, the proper way to write it would be this. Even though you're not used to things that look like that. But what that tells you is 3x minus 7 cannot be equal to 0, and that's the only restriction we have. And now if we solve that, so x cannot be equal to 7/3. In other words, it solves just like an equation. And to get that, you know how to put that in interval notation. Just like you did. Okay.
Cool.
7, the only thing, well, 7's got a couple of restrictions, right?
Yeah, it's got the x under the radical and then the x in the denominator.
Yeah, so you have to solve that inequality, which you did. X is greater than or equal to 3/2, but also x cannot be equal to 8. So, looks correct. 3/2 to 8 in combination with, I think you need a u.
Oh, yeah.
In between those. In fact, you need to use in all of these. I hadn't noticed it before, but up here on number 4,
you need
a u. Whenever you have more than one interval, you need to combine them with a u.
Oh, yeah, I just forgot.
Okay.
And then, so you just solve for the 2x minus 3, and then you just solve for the x minus 8?
Yep.
Okay, cool.
And then combine them. Now, on number 8, the numerator does not present any restrictions, but the denominator does. What inequality should I write for the denominator? X minus 1 has to be what? It's either greater than or equal to 0 or greater than 0. Which is it?
Okay.
Which is it?
Greater than?
Yeah, because this is one case where you can't have the inside being 0. Not because you can't take the square root. You can, but the square root of 0 is 0, so you'd be dividing by 0. If you ever let x equal 1, you're dividing by 0. You can't do that. So when you have your radical sign in the denominator, it's a little different than when it's up here in the numerator. When it's in the numerator, you take whatever's inside and you make it greater than or equal to 0. But when it's in the denominator, it's just x minus 1 is greater than 0. The way I've written it is where you want to start, and where that leaves you is x has to be greater than 1. And so your interval is correct. Your wording is a little screwed up there. In other words, it's not 1 that's greater than or equal to 0. It's x minus 1. And it's not greater than or equal to, it's just greater than. Which your interval notation shows that's not a greater than or equal to 1, right? Because it's a parentheses. If it was actually x is greater than or equal to 1, then you'd need a bracket right there next to the 1. But it's not. Okay, on number 9, again, the secret, when you see stuff that can be factored, factor it.
That's what I meant. Yeah.
Okay, so we got x plus 7 over, that's got to be, let's see, 14 and 2 don't subtract the 3. 7 and 4 must be x plus 7 times x minus 4. That would give us a middle term of 3x. Okay, now, if I looked at just this alone, what would I say x cannot be equal to?
-7 and then plus 4.
Well, look at this function. That x plus 7 will cancel with that x plus 7, leaving me with 1 over x minus 4. However, the domain does not change. If I look
Yeah.
strictly at that, it looks like my domain now is x merely can be anything except 4. But minus 7 sticks with it. It makes what's called a hole. Instead of a vertical asymptote, you end up with a hole. And a hole has the same restrictions as a vertical asymptote. In other words, no matter how you end up with this function, x can still not be equal to negative 7 or 4.
Okay.
Okay. So the domain restriction always comes from the original function, not the function after you've canceled out linear factors.
Okay, that makes sense. And then we can skip to 17.
Okay.
I'm just confused on that.
I said f of x was equal to x squared. What's f of 3?
9.
Okay. So whatever's inside the parentheses, you substitute for x, right? That's the rule of that game. Well, in our case, f of x is equal to 3x squared plus some unknown times x minus 7. And they're telling us that f of 2 equals 15. Well, what's f of 2 by our rules? What do you do with the 2?
Put the 2 in for x.
Okay, so what's that give you? 3 times 2 squared
Squared plus a
times 2
minus
7. And we know that's equal to 15. So now all we have to do is solve that equation. There's only one variable. So let's simplify it. 2 squared is 4 times 3, that's 12, plus 2a minus 7. Now it's fairly simple. Combine like terms, move it over, you get 10 equals 2a, a is 5.
A is 5, okay.
Okay? So that concept is a big concept where if you have a function, whatever is in the parentheses gets plugged in for x, even if it's a variable. In other words, if the question here was, okay, if that's f of x, what is f of x plus 1?
X plus 1.
Plug it in for wherever you see x.
Okay. X, yeah.
That's the rules of the game.
Okay.
You go from there.
Okay, yeah.
But
I get that.
No matter what is in the parentheses, whether it's a number or a variable or a complicated expression, even if it was x plus 1 over x minus 1, you plug that in wherever you see x. It's as straightforward as that.
Okay. I get that now.
Okay.
Okay, and then on to the other sheet.
Okay, let me get rid of this one and pull up the other one.
Okay. So these are just plugging in numbers. I got all those down. But so the
that's what we were just kind of talking about.
Yeah.
That's what.
So when it's like, look on 28. So when it's the little circle, that means g of f of 2, right?
Yes, exactly. And you always work from the inside out. Okay. So here, let's talk about that. G of f, sometimes referred to as GOF of f, is the same as G of f of x.
Okay.
So if they say, what is GOF of 2, then you're going to do G of f of 2, figure out what f of 2 is. Whatever number that is, then you're going to do g of that number. That's what you do there. And let's do that one, as long as we're looking at it. Yeah, let's do that. In other words, we have a g of x and an f of x. So let's see, we're doing 28. So the very first thing we have to do is figure out, remember what GOF is, it's this. And you have to first figure out what f of x is. Yeah, and in this case, it's 2. So plug in 2 for x. And now, what's f of 2? That's the first step.
F of 2. That is 3, 2 squared minus n plus 4. So it'd be 12 minus 10 plus 4. So it'd be
6.
It'd be 14.
6. 12 minus 10 is 2. 2 plus 4 is 6. Okay. So that's what f of 2 is. So now the problem turns into g of 6. And what's g of 6? Here's g function.
G of 6, just be 11.
2 times 6 plus 5. 17.
Oh, okay. I thought that was a minus for a second.
Yeah.
Yeah, 17.
So that's how you do these. And the key is always to work from the inside out. Whatever the inner function is, put a number on that, and then it becomes a simple problem. Okay.
Okay, that makes sense.
Those are the hardest, the composite functions. Here's an interesting one. How about 31? H of h. Yeah, what that basically means is this, and they want it h of 5, take the answer and take h of that number. So start from the inside. What's h of 5 equal to?
H of 5, which number is that?
31.
31, okay. Let me see.
Part of the key, I think, for doing these is to make sure you write it like that. Don't leave it with H0H. It's not clear what that means, whereas this is perfectly clear. You can't do this wrong if you start from the inside. So start from the inside, figure out what h of 5 is. Go up to your h function. What's h of 5?
10.
Okay. Now, that means what they really want is h of 10, right? So what's h of 10?
25.
That's the answer.
Okay. Those make sense. Okay, now down to 41 in those questions.
Okay, hold on, let me pull it up a little bit here so I can see that. Okay, average rate of change. Another way of talking about slope. That's what average rate of change is slope. Okay, so if our function is a quadratic like this, x squared minus 2x, average rate of change going from 1 to x, well, if I were to graph this thing, and that's a parabola that is a vertex on the x-axis, we want the average rate of change going, and in fact, it's not at 1. Where is it? It's at 2. That's at 2. Right? In other words, if I plug in 2, y is equal to 0, which is what I want. All right, they want the average rate of change from 1 to x. There's 1. And what's f of 1? In other words, what they want is f hold it. Let me explain this a little better. 1 second. Remember what average rate of change is Jesus, sorry.
You're good.
Average rate of change is rise over run. That's what slope is. Rise over run. That's what we want. Well, yeah. The rise is what? When I go from 1, well, what's f of 1? F of 1 is minus 1. Oh, hold it. Yeah. How can f of 1 be minus 1? It's 1 squared minus 2. That's minus 1. That means my graph isn't right. Why is my graph not right? Our vertex, when x is 0, y is 0. That's why our graph isn't right. It looks like this. When x is 0, y has to be 0, so our vertex has to occur there, and when x is 2, y is 0. That's what we're looking at. Okay, and they want the change, well, when x is 1, y is minus 1, and when x is x, y is x squared minus 2x. So if I'm going from that point somewhere to an unknown x, which I'm going to label like that, well, here's f of minus 1 right there. Well, that is f of x. So the rise here, in other words, I want the slope of that line, right? That's what they're asking for when they ask for average rate of change. They could have made it a little easier by not giving us the variable to start with. In other words, 42 would have been a lot simpler because we're not dealing with a nebulous concept of x. We're dealing with two numbers.
Yeah.
But as long as I've gone halfway here, let's finish this one, and then you'll see how much easier the next one is. The rise here is the distance between f of x and minus 1. So here's the rise, f of x minus 1. What's the run? 1. It's x minus 1. There's your answer. F of x is x squared minus 2x. So your real answer is x squared minus 2x minus 1 all over x minus 1. And that factors into x minus, no it doesn't. That's your final answer for 41. Okay? Much harder than 42, you'll see. I'm going to erase
that one. FB minus FA over BA.
Exactly. That's rise over run. In other words, for 42, it's the rise is f of 2 minus f of 1. That's the rise. The run is 2 minus 1. Now we know that f of 2 is 0. So it's 0 minus f of 1. Well, f of 1 was minus 1. Make sure you don't drop negative signs. It's the easiest thing to do in math. 2 minus 1 is 1. So the average rate of change is 1 over 1.
The slope is 1.
Yep. And that is also the average rate of change when you're going from 1 to 2. Now, on my picture, that would be, what is the slope of that line right there? That's from 1 to 2.
Okay.
And that slope ends up being 1, as well as an average rate of change. And you can kind of see why question 41 is much harder.
Yeah,
You
yeah.
have to deal with the concept of it not x not being a number, but x. Um, so they really would have been better off if they'd have put 42 and 43 together. And 43 is f of, you always put the right number first. In other words, 43 is f of 1 minus f of minus 1, and it's 1 minus a minus 1 in the bottom.
Okay.
With me?
Yeah.
For 43, and then you just have to do the math. The bottom ends up being 2. F of 1 is minus 1, and f of minus 1 is 3. So the top, I think, ends up being minus 2, if I'm not doing my math wrong. Maybe not, but it's just arithmetic at that point.
Uh-huh.
Um,
So the bigger number goes first in
yeah,
the.
in other words, the second x value goes first.
Okay.
That's why
Okay.
we did f of 2 minus f of 1, all divided by 2 minus 1.
Okay.
And on 43, we're going to do f of 1 minus f of minus 1. That's the rise. And the run is 1 minus a minus 1. So you end
Okay.
up with 2 in the denominator.
Okay.
Write the
Okay.
equation of the secant line in 42. Well,
Yeah,
this
she
is 42,
wanted us.
and what I drew was the secant line.
Uh-huh.
The secant line connects any 2 points on the curve and is not tangent to it. Okay,
Mm-hmm.
so what's the equation of that line? And we'll put it in y equal mx plus b format. Well, what do I know?
So
I know the slope, right? I know the slope is 1. I figured it out.
yeah.
Okay. Well, that means y equals 1 times x plus b.
Yeah.
Now how do I figure out b? In order to figure out the
Um.
equation of the line, I need a point. Well, what point can I plug in for y and x such that it will allow me to solve for b?
0.
Well, how about 2 for x, 0 for y?
Okay.
That's that point right. Oops, just erased it. Damn. That's that point right there.
Uh-huh.
Goes through my x-axis. I know it's where x is 2 and y is 0. So 0 equals 1 times 2, the x value, plus b. That tells me b is minus 2. Now I have the equation of the line. Y equals x minus 2.
Okay.
And when you have a line, notice one thing about that line. It did not go all the way to the y-axis.
Mm-hmm.
So you cannot read what the y-intercept is.
Uh-huh.
We don't really know what the y-intercept is. That's why we have
Mm-hmm.
to solve for it. Well, what we did
Yeah.
know is what the slope was. So I was able to get that much of it. But to figure out what b was, now just pick any point on that line. I could have picked that point. I could have picked that point. I know that when x was 1, f of x was minus 1. So I could have easily picked that point. But
Uh-huh.
the point here is a little easier. I know that when x is 2, y is 0. So the coordinates on that point are 2, 0. Plug it in for that. Let's you solve for b. So
Uh-huh.
if it doesn't go to the y-axis, you can still figure out the equation of the line. You just have to do it a little different.
Uh-huh. Okay.
Okay. What else? You want to
And
look at 45?
yeah.
Okay, hold on. Let me tighten up my picture a little bit here. I'm just going to do 45 from scratch rather than try to figure out what you've done, if that's okay.
Yep.
All right, what's the most important thing for figuring out the equation of a line? It's the number one thing you usually need.
Equation of a line, points?
Slope. Slope's magic, okay. Yes. All the way through calculus. That's what calculus is all about, is instantaneous slope. Calculus is all about the slope not of the secant line, which is average slope, but the slope of the tangent line. If we're doing calculus and I have a parabola like that, notice the slope of the tangent line changes wherever I go on the curve.
Yeah.
The slope of the tangent line is the first derivative. That's calculus, differential calculus. Well, they're leading up to it with the slope of the secant line. Because if you wanted to figure out the slope of the tangent line at a point, you start with a secant line and you let this point gradually drop down until you end up with the slope of the tangent line. So all of the math behind finding derivatives starts with the slope of the secant line.
Yeah.
So that's why they're talking about slopes of secant line here. Now, so the most important thing is slope. Well, here's our function. So let's figure out the slope. Well, we just did a bunch of problems where they were asking for the average rate of change. That means slope. So between -1 and 5. So what's my slope?
Slope is
f of 5.
F of 5 minus -1.
F of -1.
F of,
that's the rise.
1.
What's
and then negative.
Start from the x on the right. 5.
Okay. Okay, 5.
Sure the order is always the same. Notice the top is the same order as the bottom.
Okay.
Once you do that, then it won't matter which way you go. I could actually do f of -1 minus f of 5 as long as I went -1 minus 5 on the bottom. Whenever you're doing rise over run, you can go in either order, just keep it consistent. Okay, now let's fill in. What's f of 5?
F of 5, that would be, let me see.
Just plug it into what you see on my page. Pretty easy.
B3.
What's f of -1? A little harder.
-1. That'd be -27.
Positive 27.
Positive 27?
Yeah. -1 minus 4 squared is the same as -5 squared, which
is 25.
Positive 25 plus 2, so it's positive 27. Hold on. Let me erase. Let's see. We got our f of 5 was 3. F of -1 is 27. All divided by 5 minus a -1, which is 6, which now becomes -24 over 6, which becomes -4. That's our slope. That's also our rate of change. And now we have a point, do we not? One thing about as you get close to calculus, you've learned two formats for a line, right? You've learned slope-intercept, y equal mx plus b, and hopefully you've also learned point-slope.
Point-slope, yeah, that's what she wants us to write it in.
That becomes a lot more valuable when you get close to calculus. Because what you usually have is a point and a slope. So
Uh-huh.
if there's a formula that's all you need, in other words, the slope I just calculated, right? So let's fill in as much as we know. -4 was my slope. What's a point that's on this curve?
What's a point?
Pick any point you want, fill it in, come up with that x value and what the y value would be.
Just
What's
like
x?
it's
If x is 4, what's y?
X is 4.
Plug in 4 for x. What do you get?
2.
Yeah. So there's a point that's on my curve, 4, 2, right?
Okay.
I could have picked any x I wanted. I could have put x of 5. If I'd have picked 5, that's 3. So the point was 5, 3. But the point is that you only need one point. And now what is the final equation? Now that I have my 1 point and I know my slope.
So it's y minus 2, comma,
Not
-4.
Not comma, equals.
Oh, equals.
On an equation of the line.
Yeah, sorry, I messed up. -4 parentheses x minus 4.
Yeah, and that's the answer. You don't need to take that and put it into y equal mx plus b format. Point slope is every bit as valuable as slope intercept. And in fact, like I said, in calculus, it's more valuable. For one thing, you don't have to solve for b. Notice using the point slope format is all I needed was a slope and 1 point. So I do have to come up with 1 point, but that's it. And then it's one step to plug in the slope and the point. And that's your answer.
Okay. Okay. That makes a lot more sense. Let me find. We're kind of working on piecewise functions now.
Okay. I don't know if you sent me a page, but my last student also is working on piecewise function. Hold on a minute. Maybe you did send it.
No, I haven't sent it yet. I just got to send it.
Here's one. Here's a piecewise function graph.
Oh yeah, I know that. I know that one.
Okay.
But,
you want to do a different one?
Yeah, it's just a sheet.
Can you read it to me? Is it one where you have to graph it, or is it a graph that you have to come up with the equation?
It's one you have to graph it. I'll send it to you really quick.
You don't need to. Just read it. Here, I'll get you started. F of x is equal.
F of x is equal to
how many pieces?
2x.
How many pieces are there?
2.
Okay, so the first one, it's equal to 2x whenever x is what?
Whenever x is not equal to 0.
Okay. And what's the second piece?
Minus 1 when x equals 0.
Okay, let's graph that. There's only 2 places that I care about. When x is equal to 0, it's 1. In other words, I'm going to start at the bottom. Whenever x is not equal to 0, the line goes through the origin and has a slope of 2. So it's like that, only there's a hole down here, an open circle. Because at 0, it's no longer equal to 2x. It's equal to 1. Okay. Now, you want to learn very little bit about limits? Have you had any limits at all?
What do you mean by limits?
This is a great problem to talk about limits. Okay? If I said, what is the limit of this function as x approaches 0 Well, what you do is you hop on board the function and you start going towards where x is equal to 0. Well, where are we pointing to? We're pointing to a y of 0, right? That's what that limit is if I come from the left side. If I take the limit of the function as I approach x from the right side, which is to hop on board this function from the right side and start approaching x, well, I'm still pointing at a y of 0. So that's also equal to 0. Well,
yeah, I don't think we covered that yet.
Well, no, you probably haven't, but I brought it up only because this is a very interesting function because the limit of the function as x approaches 0 is actually 0, whereas the value of the function at 0, in other words, f of 0, is actually equal to 1. That's what this says. It says f of 0 is equal to 1. So its limits can be confusing in this aspect in that sometimes the limit as you approach a certain x value will not be the same number as what it actually is at that value. The limit here is clearly 0 as we approach 0.
Approach 0.
Yeah. Just an interesting aspect of this particular piecewise function. I'm surprised. In other words, this is not a typical one they would give you. What's a more typical one is what's shown on that first page there. That's a very typical piecewise function, as opposed to that, which has a hole in it. This is go ahead.
I sent you the just the first picture of the number 1. I'm gonna grab my water really quick though.
Okay, I'll bring it up. Go ahead.
Okay.
Notice your first graph isn't correct. In other words, you've graphed it y equal 2 everywhere with a hole there. Yeah. Well, it's not y equal 2, it's y equal 2x. Remember what the graph of y equal 2x looks like. It looks like that. Horizontal lines are y equal 2. That would be a horizontal line.
Oh, okay.
But the first piece is 2x, which is a slanted line. Okay. So we did number 1, right? You're comfortable with number 1?
Number 1.
Here's what it looked like. There's everywhere except at 0. And at 0, it's actually equal to 1. So that point's on the curve. We have a hole there.
So it must be a slope of 2 over 1?
Yeah. The coefficient of the x is always the slope.
Okay. Okay.
Okay.
And then...
All right, let's look at number 2. Okay. Well, let me give you just a little philosophy of how I treat these piecewise functions. Okay. I always start in this upper right-hand corner. That's where I begin. Okay? X is less than minus 2. Well, if I put a dotted line, you don't have to put a dotted line, but it helps in conceptually understanding it. At 2. Well, that first function, x plus 3, and I always work from left to right, is this area right here. That's where I need to graph my x plus 3 function. The rest, the second part of it, is wherever x is greater than or equal to minus 2. That's this whole area over here. That's where I would graph my minus 2x minus 3 part.
Okay.
You with me?
Yeah.
All right. So let's graph to the left first. Now, notice that the left function is x plus 3, right? So one way to do that would be, okay, we'll start at the y-intercept of plus 3. What's the slope? It's the coefficient of the x term, always.
1.
Okay, so I will draw my curve with a slope of 1, and then I'll go back and I'll erase this part here.
Okay.
Okay, that's a bad way to do it. Okay, you don't want to have to be erasing. There's a better way to do it. The best way to do it is to take the x value right there, plug it in, minus 2. What's y? When x is minus 2, what's y?
Minus 2, 0.
Minus 2 plus 3. What's minus 2 plus 3?
Negative, or 1.
Okay, so if this is 1, then that point has to be on my curve, right? Now, how do I draw the rest of the line to the left? Well, I know the slope is 1, so I'm going to go down 1, left 1. Put a point right there, draw the line. Now the only last thing to do, is it less than or equal or less than?
Less than.
Which means that's an open circle right there.
Okay.
Now, notice that even though it has to be less than minus 2, I still found this point by plugging minus 2 in for that. That's okay. That's okay. There's nothing wrong with that. Okay, you got the first piece right. It goes from negative infinity. The interval of the first piece is negative infinity to minus 2 with parentheses on both sides. Okay, now let's take the right region, which is everything to the right of the dotted line. Now, this is actually a little easier to graph because it does pass through the y-axis, right?
Yeah.
So where can I start here? I don't need to make up a point. I'll just start at the y-intercept because I know that this part goes through that point right there.
Negative 3.
Now what? In other words, I got 1 point on this line. I know it's a straight line. That's linear. What do I need next to find another point?
Wouldn't you just look at it since you can...
Slope. Always be thinking slope. What's the slope of that bottom function?
Negative 2.
Yeah. So to get a negative 2 slope, I'm going to go up 2, left 1. Like that. And I'm just going to connect those points in my appropriate domain. There's my slope of negative 2. In this case, it's greater than or equal, so that's a solid dot. This I don't intend to be a dot. That's just a point on the function.
Okay.
And that's how you do piecewise. Is you start from the upper right, draw that function, and then you just go each piece. Piecewise functions are really the only difficulty at all is when one of the pieces does not go through the y-intercept. Like the left half of this did not.
Yeah.
But even though you can do those the original way that I suggested, which is to draw it all the way and then just erase it. That's the easy way to do it, but I'm not sure that's... Well, I don't know that it really does make more sense. If you have more complicated functions that aren't linear, it makes more sense to do it the way I showed you. Plug in the minus 2 in for that, and that gives you a starting point. In other words, the only thing the y-intercept is a starting spot, right? Whenever you're graphing a linear function, a straight line, and it goes through the y-intercept, well, the reason you use the y-intercept is because that's a great starting point. But if it doesn't go through the y-intercept, you can start at any point you want to plug in for x. I could say when x is, well, has to be left of minus 2, but I could have said, well, how about I'll plug in x of minus 3? Well, then y would be 0. So if I went to minus 3 and y is 0, I still end up with the same line. It's just that my starting point is different. My starting point is there. And so I end up with something that looks like that also. So just always remember that when you want to graph a line, you really only need two things, a point and a slope. That's it. You don't need the y-intercept. Don't believe that everything has to go into y equal mx plus b format. It doesn't. Y equal mx plus b format is kind of tough on these piecewise functions because you frequently don't have the b value. Or if you do have the b value, like we have the b value there, but the function doesn't go all the way to the y-intercept. So the question is, where does it cross that point right there? That's the real question.
Okay, yeah, so just last thing on the first one. So it would just be 1, because x
is equal to 1 at one spot only. That's when x is equal to 0. So when x is equal to 0, right there, the function is equal to 1. So that point is on the curve. And when x is not equal to 0, well, the function is 2x. Well, what is that? 2x graphs like that. 2x goes through the origin, and it has a slope of 2. That's y equal 2x.
So the
hole right there. Because it's only that function when x is not 0. So it's not a continuous straight line. It's a straight line that has a hole at 0.
So number 1, I mean the second piecewise on there, like on the piecewise, the 1 and the x equals 0.
Yeah.
How would that one be graphed?
All right. You got the first piece is 2x on the interval.
Yeah, I got that one.
On the interval from negative infinity to 0 in combination. In other words, here's the interval. Negative infinity to 0 in combination with 0 to positive infinity. So that's the first function is in that interval. The second function, the second piece, is equal to 1, and the interval is 0 to 0, including 0. I guess that's how you would write it in interval notation.
Yeah.
So, in fact, yeah, they do ask for the domain and range. Well, if you look at our graph, what's the domain? Look at the graph I drew.
The domain would just be negative infinity to infinity?
Yeah, and including 0 is in the domain. It's just that when x is equal to 0, y is equal to 1. But clearly x can be negative infinity to positive infinity according to these restrictions on the right. Okay, What's the range from looking at the graph?
The range would be same.
I don't think you can get y to be equal to 0.
Oh, okay.
Same. It's going to be negative infinity to 0 in combination with 0 to positive infinity. I don't believe y equals 0 is in the range. It's not there because when x is equal to 0, y is equal to 1. Well, y is equal to 1 there, and it's also equal to 1 there. So 1 is certainly in the range, but y of 0 is not.
Okay.
And that's really the way you want to do all of these, is after you graph it, then figure out the domain and range by reading it off your graph. That's probably the easiest way to come up with domain and range, is to read it off of a graph.
Okay.
Okay, Cody, it's
Yep.
7. I'm going to let you go.
Cool. Thank you so much.
I hope you liked this online session better than you liked it the last time.
Yeah, I definitely liked it. It wasn't really bad at
They
all.
work pretty good. And in fact, I'm
Yeah.
almost convinced they work better. You know why? Because it forces you to put your thoughts, verbalize your thoughts, and
Uh-huh.
relay that information to me. And
Yeah.
probably a different way of thinking about math than what you're used to. Most people who do math get a pencil and paper out, and they do it all on paper, and they come up with an answer. And
Uh-huh.
when you do that, you're not forced to think about how you're doing the problem, really. I mean, you
Think
kind
about
of
it.
are, but you're not, certainly not forced to verbalize it. And being forced to verbalize it is actually quite helpful in
Uh-huh.
understanding it, I think.
Yeah.
So, and that's the one thing with online tutoring is you have to be in the mode where you're verbalizing stuff, because everything's
Uh-huh.
done on my page and I'm asking you questions about it.
Yeah.
You probably don't even
Yeah.
have a piece of paper and pencil in front of you. You generally don't need it. It's
Uh-huh.
verbal information. So,
Yeah.
but that's quite useful. And I've found a lot of students that understand that part of it, and they think it's a better way to learn. So,
Doing it. Yeah.
well,
Cool.
it's a method that is forced by online tutoring, whereas if we were meeting in person, you could actually get away with having a pencil and paper and doing these and showing it to me, and I would just read it, and it would be a different experience.
Uh-huh.
Not to mention the fact that this was recorded, and if you forget any part of it, you can go back and review it just as soon as I post it.
Yeah.
Let me make
True.
sure I have an email to send you the link on. I'm not sure that I do unless your mom put it in here. Give me an email to send the link to.
So Cody.Lawton.
Hold on a second. I got to grab my keyboard here, which was set aside for a minute.
Okay.
CODY
Dot
WTON.
at yahoo.com.
Hope you weren't one of the accounts that got hacked.
No, I wasn't. Was there some that got hacked?
500 million of Yahoo accounts got hacked.
Holy crap.
I didn't even know they had 500 million accounts. That's
Jeez.
that's a 14th of the world's population.
That's crazy.
Yeah, so the odds probably figured, but the only information they got, I think, they got your password to your email account, almost certain.
Yeah.
The biggest danger, they say, isn't the fact they'll get into your Yahoo account, it's that you may use that password for a lot of other type accounts. In other words, they may just go on to Wells Fargo and see if you have a bank account there and use that password. Now they're in your bank account. So there's some dangers to losing your password to your email accounts other than just having people be able to get into your email accounts.
Yeah, good thing I have different passwords.
That's the solution, is just have a bunch of different passwords, although that's a pain in the ass if ever there was.
It is.
So.
But thank you so much, Dave.
Yeah. All right, Cody. I will talk to you next time.
Yep. Have a good night.
You too. Bye-bye.